So reactions of alcohol, the first reaction we were discussing, that was combustion. Combustion means burning. So this was the last example which I gave. You have C2, H5, OH. You reacted with oxygen. As a result, this gives carbon dioxide because you are burning. So alcohols are flammable liquid. It can catch fire. And water H2O. So you have two carbon. So you put 2 to balance the carbon. You have 5 plus 1, 6 hydrogen. So you put 3, hydrogen is balanced. Now what about oxygen? As you can see, 2 multiplied by 2, 4 and plus 3. So there are 7 oxygen. And on our left hand side, we have 1 plus 2, that's 3 oxygen. So we want to make 7. So how we can make 7? 1 is already there. So how many I need? I need 6 more to make it 7. So that's why I put 3. 3 multiplied by 2 will make 6. So 6 plus 1, the total will be 7. Is it clear? Another example, if we have C3, if we have C3 and H7 OH plus O2. So when we burn them, what is the result? Combustion will produce carbon dioxide and water. I need 3 carbon, so I will put 3, carbon is balanced. Then hydrogen, 7 plus 1, 8, so I put 4, so hydrogen is balanced. What about oxygen? 3 multiplied by 2, 6 plus 4, I need 10, okay? 1 is already there, so here I need 9 oxygen. How I can have 9 oxygen? So I will put 9 by 2. So when I put 9 by 2, I will have 9 plus 1 means total 10 oxygen. Is it clear? This is how we balance a combustion equation. Start with carbon, followed by hydrogen, and at the last, oxygen. This is one reaction. So what happened in this reaction? It's like you have a container and you have container filled with alcohol and you place a lighted splint or a matchstick. When you place this lighted splint or a matchstick, what will happen? This alcohol will burn and give out flame. This is what happened, like burning. The second reaction is called oxidation reaction. Oxidation is having different definitions. It has definition in terms of electron, it has definition in terms of hydrogen, and it has definition in terms of oxygen also. So what is the definition of oxidation in terms of oxygen and hydrogen? Oxidation is actually addition of oxygen or removal of hydrogen. So addition of oxygen or removal of hydrogen is also called
Sir,
oxidation.
sir, the addition of oxygen is the same as combustion.
No, but a small difference is there in the two reactions. We don't have a flame in this oxidation reaction. Like you have a container, the container is filled with a flame, if a container is filled with alcohol, and this alcohol is reacting with atmospheric oxygen without supplying or igniting or burning it. So without burning, when it is reacting, we are calling this as this. The previous reaction, combustion, is also refers to oxidation, but a small difference is there between combustion and simple oxidation. In a combustion, you can see it's addition of oxygen. Addition of oxygen is called oxidation as well. That's true. But there is a small difference between combustion and simple oxidation. In combustion, we should have a flame. We should ignite. We should provide a spark to burn a substance. But in normal oxidation, we don't ignite, we don't burn. Like we have a container filled with alcohol, and this alcohol is reacting with atmospheric oxygen, and we call this reaction as oxidation of alcohol. And what is the product when alcohol oxidation occur? So when alcohol plus oxygen, it gives carboxylic acid. So alcohols form carboxylic acid when they react with atmospheric oxygen. That is why, like example, if you have a container which is filled with alcohol, even different wines and have different proportion of alcohol, but they keep the lid on this bottle. Why they're keeping a lid on the bottle? Because if the bottle is left for a greater period of a time, then this alcohol which is present in the bottle of wine, it will turn into carboxylic acid and it will turn sour. That
So,
is what.
sir,
Yes.
how are we gonna know the difference between, like, in
One is burning,
combustion the product in combustion the product is
carb
carbon dioxide,
and water.
yeah,
It's
and water.
burning. When you burn something and it contains carbon, hydrogen, and oxygen, so result is carbon dioxide and water. But here you are not burning. You have a container which is filled with alcohol, and alcohol is reacting with atmospheric oxygen, which convert alcohol into carboxylic acid. So if it is
All
butanol,
right,
it will give butanoic acid. Propanol, propanoic acid. But
you got it.
for oxidation, if we want to make this process faster, so what we do, we add oxidizing agent. So when we add oxidizing agents, the two oxidizing agents, you have to learn the name and their color changes. The first oxidizing agent, you can add potassium manganate 7. This potassium manganate 7, you don't have to learn the chemical formula for this oxidizing agent. So this formula is KMNO4. So potassium manganate 7, if you use potassium manganate 7, what will be the color change? You have to learn this color change. From purple to colorless. The oxidizing agent is having a purple color. Once it is used, oxidizing agent take part in a chemical or help in oxidation. So it will change the color. The oxidizing agent will change its color from purple to colorless. this is not called a catalyst. Actually, they are not catalysts. They are making the condition favorable for the reaction to occur. So that's why we call them oxidizing agent. Like example, if you want to travel from one place to another, you're booking a ticket by using a travel agent. So what agent is doing? Agent is helping you to buy a ticket. So same thing, oxidizing agents, what they will do, they will make a condition favorable for the reaction to occur. But it's not like catalyzing the reaction. It does not speed up the reaction. They just make the condition favorable for the reaction to occur. And when they make the condition favorable for reaction to occur, they change their color from purple or pink to colorless if you are using potassium manganate 7. And you can have another oxidizing agent which is called potassium dichromate 6. It will change its color from orange to green. You don't have to learn the chemical formula, just the name. Potassium chromate 6. It will change color from yellow to green.
Sir, is it a must to add an oxidizing agent?
Yeah, because you want the condition to be favorable. Like alcohol will convert into carboxylic acid even you leave it without oxidizing agent. But oxidizing agent make this reaction favorable, means this reaction can occur easily. So normally we add oxidizing agent so to make this reaction occur easily. So you have to learn this color change. It depends on which oxidizing agent is added. So this is a second reaction of alcohol. Addition of oxygen. So any alcohol is there reacted with oxygen, atmospheric oxygen, it will turn into carboxylic acid. So normal, these are drinkable alcohols are prepared by obtaining glucose from different fruits. Like example, grapes are used for that purpose. So they extract the glucose from the grapes and carry out fermentation. As you see, like example, that's the reason why these drinkable alcohols, which are having a greater, like left for a greater time period, are more expensive as compared to shorter time period. Because if it is left for a greater time period, the alcohol proportion will be higher. So these are the reactions for alcohol. Finish writing. So we'll discuss carboxylic acids.
Surzan,
Yes.
when they color change, it means that they've used up.
Yeah, they have used up. Means now once they show a complete color change, it means oxidizing agent is being used up. Like it cannot further make the condition favorable for the reaction. So oxidizing agent chemically they change, but catalyst chemically does not change. The difference between catalyst and oxidizing agent, like example, if a substance was a catalyst, chemically it will not change. If I say I'm using example iron as a catalyst, okay? So if I'm using iron as a catalyst, if I carry out a reaction and I add iron to this, so it will remain iron. It will not change. It will only speed up the reaction. But what happened? I was using oxidizing agent chemically it will change and it will make the condition favorable for oxidation to occur. So the substance chemical, they undergo a chemical reaction and they make the condition favorable for a chemical reaction to occur. That's the difference between oxidizing agent and catalyst. Then we have carboxylic acids. The carboxylic acid, the naming as we know, they contain C double bonded with O and OH, and the name should have oic acid. So if name is having oic acid, we call them as carboxylic acids. And for carboxylic acid, you don't have to number because this is always our first carbon. So you don't have to number, you just have to. There are branch carboxylic acid as well, but that will be complicated for O levels. So in O levels, you will find only straight chain hydrocarbons. Sorry, straight chain carboxylic acids. So there are 3 carbon atoms. If 3 carbon atom, what I will say, which prefix I will use for 3? So it will be prop, because I have 3, so it will be prop. Between the carbon atoms, they have a single bond. So it will be N. And because of carboxylic group, this whole group, it will be oic acid. So it is propanoic acid. always this is your first carbon, so you don't have to number the carbon atom. It can be on the left hand side, it can be on the right hand side. That also does not make difference to the name. It can be written like this as well, COOH. How many carbon atoms are there? How many carbon atoms? So for 5, include that one as well. So for 5, what we call pent, because of 5, single bond N, and due to this functional group of COOH, we call oic acid. So it is pentanoic acid. Pent because they have 5 carbon, N because there is a single bond, and oic acid due to this functional group C double bonded with O and OH. So carboxylic means functional group is C double bonded with O and OH, or you can also say COOH. Always this is your first carbon. This carbon is always referred as a first carbon. So if I draw a structure like CH3, CH2, CH2, C double bonded with O and OH. Now, what is the name of this compound? So what you will do, the carbon chain, when you select the carbon chain, this is always your first carbon where OH and O is attached. So you don't have to number carboxylic. Just count the number of carbon because there are 4 carbon atoms. So I'll say bute. What is the bond between the carbon atoms? It is a single bond. One all have between the carbon. We always not between carbon, oxygen, and other element. Only between the carbon because it's a single bond. So it is N. And due to this group, what will be the name? It will be oic acid. So this is butanoic acid. Is it clear? Copy this. Then how to prepare carboxylic acid? So just now we discussed the reaction of alcohol, the oxidation of alcohol. So by oxidation of alcohol, we'll have carboxylic acid. So if we have butanol or any alcohol, plus oxygen in the presence of oxidizing agent, in short, I am writing OX or OA, oxidizing agent. So it's easy to remember, like you can see the condition for this reaction to occur. You have alcohol, oxygen, oxidizing agent, OA. So what this result? This result in a formation of alcohol. Oh, sorry, carboxylic acid. Plus water. That's a complete reaction. Alcohol plus oxygen gives carboxylic acid plus water in the presence of oxidizing agent. So if you have butanol plus oxygen, in the presence of oxidizing agent, means you're not burning it, in the presence of oxidizing agent, what will be the product? If butanol is there, then which carboxylic acid will be there? Butanoic acid plus water. Same way, if you have hexanol or propanol or pentanol plus oxygen, so pentanol plus oxygen, this result in a formation of pentanoic acid plus water. This is how we prepare carboxylic acid, is by oxidation of alcohols. In the previous example also do correction, not means the product here I forgot to write water, actually water is also there. So just do correction, water is there. This was oxidation of alcohol. So the same thing, oxidation produce carboxylic acid plus water. So butanol plus oxygen give butanoic acid. Pentanol plus oxygen give pentanoic acid. Hexanol plus oxygen, hexanoic acid. Reaction condition, we need an oxidizing agent so that this reaction can proceed. Then reactions, finish writing this. This is how we prepare carboxylic acid. OA means oxidizing agent. Oxidizing agents such as, I give you 3 examples. You can use these are OA, oxidizing agents. Potassium manganate, potassium dichromate, or potassium chromate. Depends on which one you are using. So according to that, you will have a color change. Reactions of carboxylic acids. And before reaction, these carboxylic acids are weak acids. So weak acid, what is the meaning of weak acid? Acid means they tend to. So carboxylic acids are weak acid. The term acid means they tend to donate proton. Acids are proton. But what is the term weak acid means? The term acid means they donate proton.
Donating less hydrogen ions.
Yeah, that's right. Donating few hydrogen ion in the solution. So the donate proton are, but hydrogen ion is not a correct term. Can you always use the term proton or hydrogen plus charge, because hydrogen ion can be positive or negative. But when hydrogen plus or proton, you say, it means this is always. So weak means it ionize or dissociate partially. Means small amount will break down. So if you have, like example, say 100 molecules of ethanoic acid. Ethanoic acid means CH3COOH. What are the ions it will dissociate? It will dissociate into CH3COO. Just that's very easy to remember. Till the last one will be negative charge, and there will be the last hydrogen will be positive. This is how they dissociate. So, but what is the term weak means? If you have 100 molecules, but out of 100, only 2 of them will break into ions. So few molecules will break into ion. We call that as weak acid. So weak acids will have a higher pH or strong acids. Which type of acids will have higher pH? Strong or weak? For example, if I say I have a pH 2 and I have pH 5, which one is a weak acid? pH 2 or pH 5? Which one of them is a weak acid? So pH 5 is a weak acid. Then reactions of carboxylic acids, reactions are similar. Reaction rates are slower, but the reactions are similar. Yes, only one method you will learn about how to prepare carboxylic acid, and that's by oxidation of alcohol. There are different ways, but you're learning only one way. So reactions of carboxylic acid, their reactions are similar to that of normal acid. If you remember, if we have any metal plus acid, what is the product? Metal plus acid. Salt and hydrogen.
Salt and hydrogen.
So it will give salt and hydrogen. These carboxylic acids also, when they react with metal, they will also give salt and hydrogen. But how the reaction occur? I will give first a normal example, like if you was having a metal sodium. This will be explosive reaction. Practically, it's a violent reaction or explosive. But like example, you have sodium react with hydrochloric acid. So sodium will take position of this hydrogen. What will be the product? The product will be sodium chloride, NaCl, the salt, and hydrogen will be there. This is what happened for a normal acids. But now this is what happened with the normal acids or inorganic acids. But if you have organic acid, these carboxylic acids are also called organic acids. Say you have ethanoic acid or methanoic acid, CH3COH. So this is ethanoic acid and it reacted with metal. So it reacted with sodium. Okay. So what happened? Same thing will happen. Sodium will displace hydrogen. Which hydrogen it will displace? The hydrogen which is there at the last, that will displace. Now, what is the product? How to complete a product? You already learned about the concept of valency. Remember, all the carboxylic acids, their ions have valency -1. So if I want to write the formula of a compound which contains CH3COO, this valency is -1 and sodium valency is +1. So if valencies are same, charges are same, so what will be the product? The product will be CH3COONA. All these carboxylic acids, they have valency -1. So react with group 1 metal, form CH3CONA, plus hydrogen will be there, so it will be H2. We'll balance the equation later, but first thing is completing a product. Second thing is balancing an equation. Is it clear? First, this is a complete product. This is not a balance equation. But this is not a combustion equation, so carbon, hydrogen, oxygen order you will not follow here. For combustion equation, we follow that order. But normal equation, it is oxygen, hydrogen, and then any other elements. So oxygen, how many oxygen are here? 2. Oxygen 2. Oxygen is balanced. How many hydrogens are there? This will be 3 and 2, 5. So if I put 2 here, this will make 8 hydrogen.
Sir, can you explain from the beginning?
The balancing part?
The organic acid reaction with
organic acid
metal.
reactions are similar to that of metal. Metal plus acid will give salt and hydrogen. So as we know, the normal acid, the metal will replace hydrogen. Organic acid also, the metal will replace the last hydrogen. So that's why the product will be CH3CONA plus H2. And all these organic acids have a valency -1. So valency is -1, metal is +1. That's why it will be CH3COONA. Balancing part